Good morning. Just getting set up. Alrighty. Welcome to the new format of class. This is going to make for an interesting rest of the semester, but I know we can get through this as long as we're willing to continue to put in an effort, keep up with the homework, study, and of course, watch these lecture notes. So I just want to point out a couple of things before we move on, and that is um, testing. There are no longer passwords for tests. So whenever you finish the relevant homework and quizzes for those, you can go ahead and take the test at home like it was a quiz. You are still supposed to have your notes closed, follow the appropriate calculator policy. If it's part A, no calculator. If it's part B, you're allowed a calculator. And I hope that everyone will follow those. Um, I can still give you extra attempts on quizzes or tests if you ever need them. Remember, it's a 75 to pass a test, unlike the homeworks and quizzes, which are 80s. So we are going to be continuing this format for the rest of the semester, as TCC has just announced. So I'm assuming that the final exam is going to play out very similarly, but I need to talk to my department to make sure that that is the case. But again, you can email me if you have any questions. Please make sure that you check Canvas for the live videos and previous recordings. Like I said, I'm going to always, after I finish a session, I'm going to upload it to YouTube, and then I will post a link directly from YouTube into Canvas. The homework due dates are still going to be the very next class. So if we finish 212 and 213 today, for instance, that means those homeworks are due by midnight the next day of class, either 2 days or 5 days later. So again, if you have any questions, please email me. Also on Canvas, there's a discussion board on Canvas. Right now, I think I just have one posted, or maybe I still need to set that up. I am going to eventually create multiples, whether it's just chapter based, and I'm not going to be the only person answering questions. I would like student participation, not just asking questions with answering questions. So if you see someone post something and you know how to help them, please help them. Or if you think you might not have quite the best understanding of that, look into that problem more yourself as well. So I'm not going to guarantee that I'll answer every single question. Again, I want some student participation, but I will throw my hat into the ring every now and then, of course. Alrighty, so with that being said, I think we need to go ahead and continue in where we left off with 2.12. And basically what I'm going to be doing is sharing on my screen the section notes that we would have been working with in class for the most part. I'll write on the screen every now and then. I'll pull up a blank whiteboard, but I think with this, I generally like to just be able to write on this. Now, whenever I do write on the screen, if I want to be able to move it, I do have to delete all the writing that's up there. Good thing is, if you ever miss something, if it's live, that means since I'm putting it on YouTube and I'm putting a link in Canvas, that you'll be able to find it there. You can go back and you can even pause the video. So if you need to replay something, you can replay something. I am also going to be trying to throw like a little quiz in every now and then. In these lecture videos, and I'm not going to say when it is in the video. I'm just gonna, and it might not be every day, it might be every day, it might not be every day, but if I give a lecture quiz question and it'll be a simple question, I would have the quiz posted in Canvas for a response, and then everyone that watches the video should get a 100. This is just kind of a deterrent to make sure that people are watching these videos, because just like you need to come to class, you need to watch these videos. All right. So now we may begin. Okay, so read and interpret basic graphs. This section is not too bad. There's nothing overly complicated that we need to get into. Just talk about a few of the types of graphs. And per usual, we're not going to have time to do every single problem, every single type of problem, but we will cover the basic, what's the word I want to use, the basic spread of problems. So we're going to see several different types of graphs, ranging from number line graphs to bar graphs, whether they're horizontal or vertical, as well as circle graphs. But the first thing we want to do is this problem over here. Well, a few of these dealing with this problem over here. So, or this table over here, excuse me. I'm still getting used to this. So refer to the table. The table represents the 10 longest rivers on Earth. Number one, what is the difference in the length of the Nile Kajira River and the Amur Argan River? And I'm sorry if I'm mispronouncing these names. What is the difference in the length of the Nile and the Amur? So they want the difference, which means we're going to be doing a subtraction. And we have to do it in the order that they say, or at least largest minus smallest if it's not that way, since we haven't gotten the sign arithmetic yet. So we got the Nile River, which is this 4132, and that's in miles. And then we have the Amur, which is down here at the bottom, and that's at 2763 miles. So those are the two numbers that we need to subtract. So we got the sorry, I have to switch some modes here. The Nile, which was the 4132, and then we're going to subtract off the Amur, which was the 2763. And if we do that subtraction, remember, you're allowed a calculator at this point. So I'll act like, oops, calculator for C. I'll do it the way y'all probably would at this point. So 4132 minus 2763, and we get 1369. 1369, and that is in miles. That's our answer. And again, we just subtracted them because they told us to take a difference. We used the Nile and the Amur values because they told us to use the Nile and the Amur values. Next question they've got, in what continent does the longest river lie? So we're looking for the largest number here. And if you actually notice, if you look at these numbers, they're going in descending order. This first one's a 4,000, then some 3,000s, 391, 390, 344, 33, all the way down to 2763. So in fact, the longest river is at the top, and it's the it's the Nile Kajira, however you say that. I'm just going to say the Nile. But they ask, what continent does the river lie in? And the continent is Africa. So that's our answer. Which river among those listed is the shortest, and in which continent does it lie? We noticed earlier that these were in descending order, meaning that the smallest is at the bottom. So that's 2763. They wanted to know the river and the continent, so it's the Amur. I'm just going to write the first part, and then it's in Asia. Number 4 is very similar to number 1. I'll leave you to find that on your own, to work that on your own, but it should be 872 miles after you do that difference. Another difference in number 5, how much longer, what is the difference between the lengths of the longest river in Asia and the shortest river in Africa? This one involves a little more work, so we'll do number 5. What is the difference between the lengths of the longest river in Asia, So we got to find the longest river in Asia and the shortest river in Africa. So we got to be careful. We need the longest from Asia. So out of the different ones in Asia, we want the one at the top, which is the Yangtze, and that's 3917. So we're going to do 3917 minus. And now we got to find the shortest river in Africa. So probably best to be at the bottom. Here's the first Africa, 2922 for the Congo. So 2922. And again, because I know that a lot of us are going to use our calculators, even though that we know how to do that subtraction, it's just a time-saving element now. 3917 minus 2922, and we get 995 miles. What is the continent with more rivers among those listed? So we're looking for the continent that has the most rivers. So we might have to kind of count these out. South America seems to have 2. North America's only got 1 listed. So North America is out. Asia, 1, 2, 3, 4, 5. So that might be an answer. So we know that South America's out as well. What about Africa? I see 1 for Africa. I see 2 for Africa. And that's it. So definitely Asia with their 5. All right. So that's just using a table in order to get some answers. And in some of those problems, we had to do some math. Some of them, it was just identifying where there were more of one thing or another. All right, so let's move on. And the next thing we wanted to do, we don't have time to do all these drawing of bar graphs, unfortunately. It would just be very, very time consuming to do with this pen. So I'm gonna leave questions 8 and 9 out. But the basics here is, all right, number 8, they want a bar graph with vertical bars to illustrate. So if you try and do that on your own, you should be drawing something that looks kind of like this. You'll have a chart here and some numbers on the left. So maybe 0, 2, 4, 6, 8, 10, 2, 4, 6, 8, 10, 12, and that would keep going. Over here, you might have a spot for Bangkok, and I can't write vertically very easily on this. Wait, I have an idea. This is weird. You have a line for Bangkok, then you could have a line for London, et cetera, et cetera, et cetera. So 1 for each of those. And then their bars would be as high as the value. So Bangkok's about 16. So let me just go ahead and make a few more numbers up here. 14, 16. So you'd have a bar about this high for Bangkok. And you can shade that in or leave it unfilled. It's up to you. So you do that for each of these. And you don't necessarily want it on the exact whole number. So like, what's a good one? Kuala Lumpur, so 9.2. So if I do this scale where I'm going up 2 with 9.2, they would probably be about somewhere here, about a height there, halfway between the 8 and the 10. Okay. Line graphs. So these are often used to track how one variable changes with respect to a second variable. So we just saw what a bar graph would look like, and those can be vertical or they can be horizontal. And question number 9 asked to draw a horizontal bar graph. So instead of the bars going up and down, they'd go left and right. Line graphs are going to look more like this, where you plot some dots and then connect them with little line segments instead of drawing a vertical bar or a horizontal bar that are all then disconnected. So this is what a line graph is going to look like. And this is kind of an interesting, that is an interesting problem. So the figure And yes, that graph does go. No, that's unemployment rates. Sorry about that. So the figure shows the data shown here. Wow, that's a very poorly phrased sentence. All right, so this table has the weight of Miguel and Mario to describe their weight loss. Use the data given in the table to create a line graph. So again, this is going to be kind of difficult to do with this setup. I'll do the best that I can. So I need to go back to annotate. And we're going to have this be 180, this be 175, 185, 190, 195, 200, 205. And I'm only going to do, let's see, let's do Miguel first. I was thinking about just doing one of them. Let's see if I can make this good enough. So in week 1, and we got to do the weeks, and we're going weeks 1 through 9. So week 1, 2, 3, 4, 5, 6, 7, 8, 9. And the good thing is you won't have to do this by hand in your homework or testing. This is more of just a demonstration. So in week 1, Miguel weighed 198. So we're going to have a blip right about here. That's about 198 for Miguel. Then week 2, he's at 196. So a little lower, but not quite at the 195. Then at week 3, we're at 196 again. He plateaued. Week 4, we're at 193. So we got another drop. Week 5, we're at 191. Week 6, we're at 190. Week 7, we're at 188. So we're still dropping. Then at 187. And then at 191. So we gained a little. Miguel gained a little that last week. And all we do is just connect these with a bunch of little line segments. And these are supposed to be straight, but this tablet is a little difficult to work with. So just imagine that those are all straight lines and not curved. So this would be Miguel. I think there's a way for me to change the color. Yes, all right. So now let's do Mario. He started out at 203, so about up here. Yeah, look at that. Then he's down to 200. Then 202, so he bounced back a little early, but that's okay. Then 198. Then at 197. Then at 196, just kind of a slow and steady drop for a bit. Then one back up to 199. So week 7 was a little rough. 194. That was a bigger drop down to about here. And then 193, maybe about here. Boom, 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 boom. So that would be Mario. All right, so use the data given to create a table. There we go. There's A. In week 9, who lost more weight, Miguel or Mario? So in week 9, Miguel went from 187 to 191. That's not even a loss, that's a gain. Mario went from 194 to 193. So Mario lost a pound, Miguel gained 4 pounds. So definitely Mario, because Miguel gained. C, use the trends in the graph to predict the Miguel weight and Mario weight in week 10. This is where things get a little weird because these are not consistent. Some weeks people are up, Like if you look at this, Miguel at that very last week went from 187 to 191. So you might say, well, if you only look at this trend, Miguel's weight's going to go up. But the thing is, all the other weeks he was going down, he was going down, he's going down. So this is probably just a fluke. And the next week it's going to go down again. Now, I will tell you what the textbook has as an answer, but it's, in my opinion, not a great answer. They say, I need to switch my color again. Let's go back to blue. They say that Miguel could be about 196, but I'm going to say that that's not really a good answer. I say he goes down, let's see, he seems to lose about a pound or two every week. So he's probably going to be in the 189. And I'll say ish range. This is not the type of question that you're going to see on a test because it's a very, very, very loose format. All right. So Mario, now again, they just kind of look at only the most recent trend. They say he went from 194 to 193. So they're going to say he probably only loses a pound, so maybe 192. And again, I'm going to say ish because I don't necessarily think that. I think he might maybe lose 2 pounds. He might maybe lose 3 pounds. This isn't enough information to go off of. So kind of a weak question, but it is what it is. All right. There's another line graph. We're going to move on to the circle graph. And let's see. The figure represents the results of a survey of a local ice cream store to its customers on flavor preference from a list of 5 ice cream flavors. What is the total number of participants in the survey? Well, we got 6 people that liked Neapolitan, 60 that liked vanilla, 45 chocolate, 24 butter pecan, and 15 strawberry. We're just going to add those up to get the total. So we're going to go 24 plus 15. That is a really terrible looking plus sign. Plus 6 plus 60 plus 45. So 1, 2, 3, 4, 5 values, 1, 2, 3, 4, 5 values. And if you add those up, I'm not going to pull out the calculator this time. 24 and 15 is going to be 39. 39 and 6 is 45. I'm going to add the 45 and the 45 at the end to get 90, and then 90 and 60 is 150. Remember, with addition, you don't have to necessarily add from left to right as long as it's all addition. So it's 150 participants, 150 people. What was the most popular flavor? Well, just look where the biggest number is. No, definitely not Neapolitan or strawberry. Definitely not butter pecan. Vanilla seems to have the most. Plain flavor, but there can be good vanilla out there. What was the least popular flavor? Well, the one with the smallest number is definitely the Neapolitan. How many more people preferred vanilla to chocolate? So we need the vanilla and chocolate numbers, which are 60 and 45. So we go 60 minus 45, which is 15. What percent of the surveyed people preferred vanilla? What percent of the surveyed people preferred vanilla? This is what's known as a part to whole ratio. We talked about those in class very briefly a few weeks ago. Part to whole, so we want the ratio of the vanilla people to everyone. So we want vanilla over all the people. Well, there were 60 people that, sorry, I keep clicking my pen. There were 60 people that liked the vanilla, and there were 150 people that participated in the survey altogether. Now we're going to have to convert this fraction to a percent. Remember, there's multiple ways to do that. I'm going to reduce this fraction before doing anything, though. The zeros are just going to cancel each other out. That's like dividing by a factor of 10. So that's 6 over 15. Put 6 over 15. 3 will go into both of those. 3 will go into 6 twice. 3 will go into 15 5 times. So that's 2/5. Now you could convert this to a percentage by multiplying it by 100%. But I know that most of us are going to convert this to a decimal first, which is 0.4. 2/5 is 0.4. You can just do the division with or without a calculator. And then moving that decimal right twice to give us a percent is 40%. So 40% of the people preferred vanilla out of everything. How many times more people preferred vanilla to butter pecan? This is going to be similar to the last one, but instead of comparing part to part, instead of comparing part to whole, this is one part to another part. And we're specifically comparing the vanilla and the butter pecan. So the vanilla is what's going to go on the top, which is 60. The butter pecan is going to go on the bottom, which is the 24. And if you do that reduction and division, I'll leave that to your own accord. You'll end up with 2.5. So that's 2.5 times more people prefer vanilla to butter pecan. So in other words, for every one person that likes butter pecan, there are 2.5 people that prefer vanilla. Or if you wanted to have that in terms of whole people, you could say for every 2 people that like butter pecan, there's 5 people that like vanilla. And we don't need to get into the reasoning for that part. That'll be good enough. Okay, so there's not a whole lot of stuff going on with 2.12. As I said, you're not going to have to manually draw any of these charts. The homework, the quizzes, the tests, they'll all be up there because how would Connect Math ever test you on making a chart like that? So you just have to be able to pull the information from the charts, which we practice a decent amount of. So with that being said, oops, I didn't want to take annotate off yet. Let's clear our screen and let's go to the next section. 213. 213, the US and metric systems of measurement, specifically length, weight, and capacity, and this is section 213. Length, weight, and capacity. Another word for capacity that you might be familiar with is volume. Volume typically measured in things like fluid ounces or gallons or liters. So with this section of problems, as well as the next section of problems, there are 2 different types of problems. You have the US type of problem, and you have the metric type of problem. So the US problem is going to use something called dimensional analysis. I want to pull up just some typing for a little bit. Dimensional analysis. You may have heard of dimensional analysis back in a chemistry class or a biology class, or maybe even an Algebra 1 or Algebra 2 class, depending on how much math you've been through previously. But this is a whole system about converting from one unit to another unit using fractions as multiplications. So this is a way of converting from one unit to another by multiplying by a fraction the fraction in the top and bottom has equivalent values, but in different units. For instance, 1 foot is 12 inches. So you'd multiply by a fraction that's 1 foot over 12 inches, or you'd multiply by a fraction that's 12 inches over 1 foot. So if you were converting from feet to inches or from inches to feet, this is what you would do. You would just take your original number and you have to write the units. You must write the units, you must write the units, you must write the units. Nobody wants to write their units, but if you don't write your units, you're going to make mistakes. I guarantee it. So if you wanted to convert from feet to inches or from inches to feet, you would either multiply by 12 inches over 1 foot, or 1 foot over 12 inches. But the question is, how do you know which one to do? And I have this whole concept that's out with the old, in with the new. What that means is you will make sure that the old units are in the bottom of the fraction. You're going to make sure that the old units are in the bottom of the fraction. What this will do, this will ensure that the old units cancel and you are left with the new units. Let me show you what I mean with a quick little problem. So this is not a problem from what we'll see later, but let's just convert 2 feet to inches. So what we do is we write the 2 feet first. Now, I really hope that everyone knows that 1 foot is 12 inches. That is something that I expect my students to have memorized. However, every single unit conversion that you need for this course is going to be in your formula sheet that is inside of Connect Math under your resources, the same place where you can find your syllabus. Remember, you are supposed to print that out for your test 2 and 3 and the final. You are allowed those formula sheets for anything involving chapter 2, chapter 3, and the final exam. Obviously, I can't print them out for you. So please, please, please make sure you print those out ahead of time. Yeah, so 12 inches is 1 foot. 12 inches is 1 foot. So we're going to multiply by a fraction that has the 12 inches in the top or the 1 foot in the top, and then the other one's in the bottom. Because our old unit is feet, we want to make sure that the old units are in the bottom of the fraction we multiply with. So when I multiply by a fraction, please pay attention to how I do this. I'm not going to write the 12, I'm not going to write the 1. Before I even look at that conversion factor, the conversion factor being that one thing is the same as another thing in different units, all I'm going to do is I'm going to say, all right, my old units are feet in the bottom. I know I need feet in the bottom. I absolutely have to have that. That way, we will out with the old and in with the new, because you have a feet on top and a feet on bottom, they'll cancel. Just like if you have a 3 on top and a 3 on bottom of a fraction, they cancel. Just like if you have a 7 on top and a 7 on the bottom, they cancel. They don't even have to be inside the same fractions if they're multiplying. So I know that those feet are going to cancel. All right, well, what is the rest of this? Well, it's 1 foot, because that says 1 foot. I write a 1 here. And then the other part is the 12 inches. So I write 12 inches in the top. Again, I didn't pay attention to any of the numbers up here. The first thing I did was I had my old units of feet, so the old units of feet here. Okay. So our feet cancel. That's the same thing in the top, same thing in the bottom, they're gone. Now we just got to do the math that we see. Well, here's a 2 in a top, here's a 12 in a top, so we multiply. 2 times 12 is 24. And the only units we see left over are the inches, so I know that this has to be inches. Let's show you what this would look like if it was wrong. And I wish I had red for wrong. I already used red though, so let's do brown. So this will be wrong. This would be the wrong way. And I want you to see this, because if you actually pay attention, if you write your units, you'll see that this is terrible. If I had done the 2 feet times, all right, let's say I didn't pay attention to my old units or feet, so I know feet go on the bottom. I just see the 12 inches in the 1 foot, and I go, oh, okay, 1 foot goes in the top, and 12 inches go in the bottom. I'm rushing, I'm rushing, I'm rushing. Now this time, the 2 in the top and the 12 in the bottom, they're not going to multiply, they're going to divide. And 2 divided by 12 is going to be a continued decimal of, what is that, 0.16. That's 0.166666, so 6 bar. Now, the feet are in the top and the bottom, so they don't cancel, they actually stack. Just like 3 times 3 is 3 squared, or 9 times 9 would be 9 squared, or 5 times 5 would be 5 squared. A feet times a feet is a feet squared. There's still the inches in the bottom. We didn't cancel them, so they have to come with. So this is 0.166666 feet squared per inch. I have no idea what a feet squared per inch is. I don't think most people are going to know what a foot squared per inch is. And this doesn't make sense. 2 feet, a foot is a lot longer than an inch. So how is 2 of something in feet less than 1 inch? And again, the units are trash. This number doesn't make sense. This is absolutely terrible. Dimensional analysis, out with the old, in with the new. Before you start paying attention to the numbers, instead of trying to put them top and bottom, just look at what you're starting with, feet. So that says feet goes in the bottom. All right, I have to clear this. Let's go back to our worksheet. So you can see this little blue section right here has got some conversions. Right there. 1 foot is 12 inches. We just used that. 1 yard is 3 feet. 1 mile is 5280 feet, et cetera, et cetera, et cetera. The right side has them as fractions. Quite honestly, I wouldn't use these. I would just use the left side. I'm not saying you can't use them because these are equivalent relationships. But the ones on the left are a lot better with this dimensional analysis idea. So let's try out, let's go with B, C, and D. B, C, and D. B, C, and D. And I'm going to need to pull up a whiteboard for this. So with B, we're converting 45 feet. We want to make this yards. I'm just going to go ahead and write these up here all at once. I'm not going to have enough space on the other screen. 9 feet to inches. And then for D, we're going to go, oh, I just realized they wrote D twice. We're doing what should be F. So let's scratch that out. It's going to be F. And that's 5 miles, and we're converting that to yards. And let me just write these little conversion factors up there. And if you can't see what's happening, actually, you should be able to see. I did the share. We're good. All right. So we said that 1 foot is 12 inches. 1 yard is 3 feet. 1 mile is 5280 feet. 1 mile is 1760 yards. Okay. So for B, we're starting out with 45 feet. And we want to multiply that by a fraction to go from feet to yards, from feet to yards. Well, this right here says 1 yard is 3 feet. So there's our fraction that we're going to multiply by. So the 1 yard and the 3 feet are going to go on the top and the bottom. It's just a matter of where. Out with the old and with the new. The old unit's feet. So feet are going to go on the bottom, which tells me the yards go on the top. The 3 goes with the feet. Make sure these numbers go appropriately. I can't tell you how many people I see put the 3 on top and the 1 on bottom because they're not paying attention. So 1 yard is 3 feet. Again, how did I know the feet go on the bottom? Because we started with feet. Out with the old. And then 45 and 3, the 3's in the bottom, so this is a division problem, and 45 divided by 3 is 15. So this would be 15 yards. All right. C. Starting with the 9 feet, we're going to multiply by a fraction. Oops, wrong color. So we got to multiply by a fraction, and we're out with the old and with the new. So again, because this is feet, I don't even have to look at what units we're going to. I know the feet have to go in the bottom. Now we are specifically going to inches as the problem requested, so inches go on the top. And we know that 1 foot is 12 inches. Out with the old, the feet will cancel. 9 and 12, they're multiplying this time because the 12 is in the top. And 9 times 12 is, what's that, 108. The units that we see left over are the inches. So that's 108 inches. Next up, we got F. Oh, pardon my scribble. We started with 5 miles. We're multiplying by a fraction. Now, again, I'm not even going to look at, oh, we're converting miles to yards. I mean, I did just look at it, but I don't have to do that. Since I know we're starting in miles and we're trying to change units, miles go in the bottom of this fraction. What units are we changing to? Yards. So yards go in the top. What's the conversion factor between miles and yards? It's right here. Do you have to memorize that? No, it's in a table for you in your formula sheet. So 1 mile is 1760 yards. So the 1 goes in the bottom, the 1760 in the top, and 5 times 1760 is 8,800. That's 8,800. We know the miles are gone, out with the old, in with the new. We're left over with yards because we didn't cross them out. And there we are. That is dimensional analysis. That is half of this entire section, pretty much. Occasionally, you'll have to do this fraction multiplication more than once, and we will see that sooner than later. But the trick is just understanding that you need to find the conversion in a table, and then you're multiplying by a fraction where your old units with its number go in the bottom, the new units with its number go in the top. That's the whole concept of dimensional analysis. Empires were built on dimensional analysis. All right. We did all those. We did not do all of those, obviously. What's the next thing I had? Let's go to the time. So time, this table has pretty much everything that you need. And this, I believe, is the table that you will find in your formula sheet. Very similar in appearance. So here's the 4 that we were just dealing with in length. So 1 foot is 12 inches, a yard is 3 feet, et cetera, et cetera. Here's time. It is my opinion that everyone should know every single one of these. A year is 365 days. Yes, technically 365 and a quarter because leap years, but no one says that really. A week is 7 days, a day is 24 hours, an hour is 60 minutes, a minute is 60 seconds. Please memorize those. If you have me in quantitative reasoning, those will not be in a table for you. You will have to have them memorized, and there's students who mess up because they haven't memorized those. Weight, a pound is 16 ounces, a ton is 2,000 pounds. Capacity, 3 teaspoons is a tablespoon, a cup is 8 fluid ounces, a pint is 2 cups, a quart's 2 pints, a quart's 4 cups, and a gallon is 4 quarts. So let's do 7 weeks to days. Let's do number 8 and 9. No, let's do 8, 9, and 11. We're going to do 8, 9, and 11. All right, so I need to pull up the whiteboard. Let's go to another page. 8, 9, and 11. I have these in front of me, so 7 weeks to days was number 8. Number 9 was 360 hours into days. Number 10, I'm sorry, no, number 10, we said we'd do 11. 11 was 13 hours in the seconds. Okay, so number 8. You're starting out with 7 weeks. Write your units. If you don't write your units, you can't do dimensional analysis. It's impossible. times. Now, weeks to days, weeks to days. If you remember earlier, we said that 7 days was the week. So there's our conversion factor. So out with the old, we see that we started with weeks. So weeks is in the bottom, meaning days goes in the top. And we said that 1 week was 7 days. Nobody cares about the extra plural, the S there. Out with the old. 7 times the 7 is going to be 49. That's 49 days. So 7 weeks is 49 days. If you divided by the 7 instead, you'd end up with 1. And 7 weeks is definitely not 1 day. Again, ask yourself if your answers make sense. That's something I heavily emphasize, especially when you have me for QR, if you have me. 360 hours. And you can abbreviate your units. You can spell them out. That doesn't matter as long as you can understand what they are. Please be careful with meters and miles. Meters is M, miles is MI. We got to multiply by a fraction to out with the old and in with the new. We're trying to go from hours to days. Well, hold on for a second. Let me pull up that table again. Hours to days. We see here that 1 hour is 60 minutes. That's not going to be helpful. We see that 1 day is 24 hours. There we go. So 1 day is 24 hours. So there's our conversion factor. So we're going to multiply. Sorry, I got distracted. 360 hours, out with the old, hours, in with the new, days. And we know that, is it 1 hour is 24 days? No, it's 1 day is 24 hours. And if you do that division, 360 divided by 24, you should get 15, right? Yes, 15. The hours are gone. We're left with the days. So 360 hours is the same thing as 15 days. Hours go by quicker than days, so it makes sense that that number is larger. And then here's where things are going to get interesting finally. 11. Starting with 13 hours. So we're going to multiply by a fraction to try and go from hours to seconds. And again, we'll pull up that table, hours to second, hours to seconds. Hours to seconds. I'm not seeing hours to seconds anywhere up here. I see hours to minutes, and I see minutes to seconds, but I don't see hours to seconds. What this means is we need a middleman, and you might need multiple middlemen with these types of problems. It's not always just multiply by one fraction. Sometimes you have to multiply by 2 fractions, sometimes 3, sometimes 4, sometimes 5. So you've got to kind of trace a path here. So I know I can go from hours to minutes, and then I can go from minutes to seconds. From hours to minutes to seconds, hours to minutes, and then from minutes to seconds, using these 2 conversions right here. Now this is going to be 2 separate fractions, and you have to cancel your units appropriately. So we were starting with hours, so we need to use the top one first. We'll do the bottom one second. So an hour is 60 minutes, a minute is 60 seconds. So multiply by a fraction. We got to go from hours to minutes first. Out with the old, so hours go on the bottom. That means minutes will go on the top. And it's 1 hour is 60 minutes. Again, I wrote that hour in the bottom before doing anything else. That way I know we're out with the olding. But this would leave us with the units of minutes, and that's not what we want. We want units of seconds. So we need a second fraction multiplier. So we're going to multiply by another one of these things. So we got rid of the hours, which put us in minutes. Now we want to get rid of the minutes. So out with the old, minutes go on the bottom. And we need to get seconds. And we know how many minutes to how many seconds. It's 1 minute is 60 seconds. So that way, the minutes now cancel. There's one in the top, one in the bottom, so they're gone. And then we're just doing the 13, 60, and 60 appropriately, which they are all in the top. So we're going to multiply all those. And if you take out your calculator, 13 times 60 times 60, pull that up on mine because I don't want to do that in my head. It's 36 times 13 with 2 zeros. What's that? 46800. So 46,800. And then the only units we're left with are the seconds. So 13 hours is a whole lot of seconds. So that is a much more interesting problem because of the extra fraction. And again, you could need a third one, you could need a fourth one. If we tried to go from, say, years to seconds, you would need a whole bunch of fractions because you'd have to go from years to days, then from days to hours, then from hours to minutes, then from minutes to seconds. And every one of those would be a fraction. So from years to days is 1, from days to hours is 2, from hours to minutes is 3, from minutes to seconds is 4. So there would be 4 of these fractions. Excuse me. And you have to make sure that you're out with the olding, in with the new each time. It's very easy to make mistakes with this if you're not paying attention, if you're not taking your time. All right. How about 13 and 14? Let's do 13 and 14. 13 and 14. Just gotta write my problems first. So 13, that's 5.5 pounds, and we're going to ounces. 14, oops, this is the 22,400 ounces, and we're converting to tons. So as a reminder, 16 ounces is a pound, is 1 pound, and 2,000 pounds is a ton. I'm on whiteboard, right? Yes, I am. Okay. So 13. 5.5 lbs, pounds. We know we're going to multiply by a fraction, and we know to out with the old and in with the new. So I absolutely know pounds go in the bottom. Without doing anything else in that fraction, pounds have to go in the bottom, so that we'll out with the old. And our goal is to end up with ounces, and maybe there's a way to go straight from pounds to ounces. In fact, there are. We just said 1 pound is 16 ounces. So the 1 pound goes in the bottom, 16 ounces goes in the top. And if you take 5.5 times 16, you'll end up with what? That's 88. Pounds cancel, so we're left with ounces. 88 ounces. 14. What? We start out with a big number, 224,000 ounces. And we are trying to convert that to tons. I don't see anything over here that says this many ounces is this many tons. I see ounces to pounds, and I see pounds to tons. So we're going to have to go from ounces to pounds to tons. This is going to be a double fraction, like the problem 11. Before I do anything, I know ounces go in the bottom because out with the old. That will make those cancel. Everything else is based off of that. So the only conversion we have from ounces is to pounds. 16 ounces is a pound. So 16 ounces is 1 lb. But pounds is not where we need to end up, so we need another multiplier. So next we're going to multiply by a second fraction. We're left with pounds at this point, so we know we got to get rid of the pounds. So they'll go on the bottom so that these will cancel. And if we're getting rid of pounds, we're trying to get to tons, and we know that 2,000 pounds is 1 ton. So 2,000 pounds is 1 ton. Because the 16 and the 2,000 are in the bottom of these fractions, they're both going to be divided. Things in the bottom get divided, things in the top get multiplied. That's 224,000 divided by 16 divided by 2,000. And if you do that, you should end up with 7. Sorry, it's just hard to put a calculator and the whiteboard on the screen at the same time. It actually is impossible. So it's 7 tons. That sounds like a lot more weight when you say it is 224,000 ounces, 7 tons. I mean, a ton is a lot more weight, but it just doesn't have as big of a, pardon the pun, weight to it when you say 7 tons. It sounds like a significantly larger value when you say it is 224,000 of something. But when you say it is 7 of something, it makes it seem comparatively smaller, even though these are exactly the same value. There's nothing different between them except for their label. That's all it is. All right. Let's go back. And let's do 18, 20, and 21. 18, 20, and 21. So 16 fluid ounces, and we're going to convert that to cups. A C just stands for cups. We're going to convert 2 quarts to gallons, and then 9 gallons to pints. PT is pints. Pull up our whiteboard. New page. So I said 18, 20, and 21. 18 was 16 flazes, fluid ounces. Now an ounce is not a fluid ounce. And we're converting to cups. Then 20, we were doing 2 quarts and converting that to gallons. And 21, we were converting 9 gallons to pints, I believe. Yes. And we have our table from before. There's a lot of things I have to write really quickly since this is the whiteboard. I'm going to skip the first one because we're not going to do any teaspoons and tablespoons. So 1 cup, we said is 8 flazes, fluid ounces. Then we had 1 pint was equal to 2 cups. Then we had 1 quart, QT for quart, is 2 pints. Then we had 1 quart is 4 cups. That's cups, sorry for the sloppiness there. And then 1 gallon is 4 quarts. Now, there are some other conversions that we don't have in the table that maybe you might want to memorize. If you want to memorize that a gallon is 128 fluid ounces, that would be excellent. If you wanted to memorize that a quart is 32 fluid ounces, that would be excellent. If you wanted to memorize that 16 fluid ounces is 1 pint, that would be excellent. So 18. We're starting with 16 flazes, fluid ounces, and we know we're multiplying by a fraction. We know we want to out with the old, so we know that fluid ounces go in the bottom. And we're trying to convert to cups, and there is a direct conversion between cups and fluid ounces. A cup is 8 fluid ounces. So that's 8 fluid ounces is 1 cup. The fluid ounces cancel. The 16 and the 8, top and bottom, so we divide. 16 divided by 8 is 2. So that says that 16 fluid ounces is 2 cups. Not 19. 20. Sorry about that. 2 quarts, and we're trying to convert this to gallons. So we know we're multiplying by a fraction. We know that the quarts go in the bottom, out with the old. Now, I see that a gallon is 4 quarts right here. So there we go. That would go between the 2 units, quarts and gallons. 1 gallon is 4 quarts. So the 4 quarts is in the bottom. The 1 gallon is in the top. The quarts will out with the old. We'll still have our gallons. And 2 divided by 4 is a half being 0.5, so 0.5 gallons. Here's a good reason why we write our zeros in front of decimals. Because without it, that might have looked like 5 gallons because of my weird marker. 21, sorry about that color. Starting with 9 gallons. We know we're multiplying by a fraction. We know that we're going to out with the old, so gallons have to go in the bottom. Now I'll actually look at the problem. We're going from 9 gallons to pints. And the only thing with gallons I see goes to quarts. But then I see something that goes from quarts to pints. So we'll need to use this one first. And then we'll need to use this one second. So the gallons to quarts, so we know quarts will go on the top. And we said that 1 gallon is 4 quarts. See, in the last one, we did 1 over 4. This we do 4 over 1. It's all about out with the old. So the gallons will cancel. But then we're going to need a second multiplier, second fraction. And this time the old is quarts, so quarts go in the bottom. And we said that 1 quart is 2 pints, so we put the 1 quart in the bottom, the 2 pints in the top. The quarts will be gone. And then the 9, the 4, and the 2 are all in top, so we multiply. 9 times 4 is 36. 36 times 2 is 72. So 9 gallons is the same thing as 72 pints. So these problems are all about what? Out with the old, in with the new. These problems are all about, look at your original units before you do anything. Multiply by a fraction and put the old units in the where? In the bottom. That way the old units cancel and you'll be left with the new units. Now this is the way of converting things in the American system, and it is also the way of converting things when we need to go between the American and the metric system in a later section. But what's interesting is when we're just converting in a metric system from metric to metric, say from meters to centimeters, or from liters to milliliters, you don't have to do any of this. That entire system is based around just moving a decimal left or right a certain number of times. And what's very convenient for us is it's in our formula sheet. You're going to see everything lined up as it should be, and you just place your dot at one place and you move it left or right until you get to where it's supposed to end at. So with our last few minutes, let's talk about that a little more in depth. So dimensional analysis is used for converting American units. For the metric system, it's all about moving decimal places. So you will use the provided metric line in the formula sheet. Now, I would advise you not to just have this printed once and constantly writing over this and erasing it, because you'll need to do this for every single problem. So you might want to rewrite this on a scratch piece of paper for every problem. And all it is a line that has kilometers, then hectometers, then decameters, then meters, and you'll see this in just a second. What you'll do is start at the location of your original units, move left or right to the new units. The number of times and direction that you move is what you do to the decimal. It's as easy as that. So if you have to move 3 times to the right to go from your old to new units, that's exactly what you do to your decimal. If you have to move 5 times to the left to go from your old to the new, that's exactly what you do to your decimal place. So I'll leave this up here for about another 10 seconds. Now remember, these are all recorded. So if I move too quickly, you can go back, watch the YouTube video, you can pause, you can rewatch. It's actually convenient. All right. This is what I was referring to earlier. This is what you will see in your formula sheet. So whether you're talking about lengths, which are measured in meters, or you're talking about capacity, which are measured in liters, liters, I know they rhyme, or if you're talking about mass, which is in grams, these prefixes are the same for all of them. So a kilogram is 1,000 grams. A kiloliter is 1,000 liters. A kilometer is 1,000 meters. It's the same for the rest. A decimeter is 1/10 of a meter. A centimeter is 1/100th of a meter. A millimeter is 1/1000th of a meter. So again, all you would do is something like this. All right, let's say I wanted to convert from meters to kilometers. Let's just say, without an example, we were going from meters to kilometers. Here's meters, so I start with a little dot here, and to get to kilometers, I gotta go left. So we go left 1, 2, 3 times to get to kilometers. So that would be 3 times left, not times as multiplication, just a number of times. And that's exactly what you would do to your decimal. So let's say we started out with 5 meters. Take the 5, its decimal is originally behind it. 1, 2, move it left 3 times. Put your filler zeros in as appropriately. So that would be 0.005 kilometers. That is the entire metric system conversion. I could stop right there and say, have a good day, but of course I'm not. We're going to do a couple examples. Now again, this line is provided to you on your formula sheet. So you don't even have to memorize that a kilometer is bigger than a hectometer, is bigger than a decameter, is bigger than a meter, is bigger than a decimeter, bigger than a centimeter, bigger than a millimeter. You don't have to worry about swapping these and putting the millimeters on the left and the kilometers on the right. So it's very, very convenient. And whether or not I think that should be on the formula sheet doesn't matter. It's there, so you are free to use it. Okay. Oops, that too soon. Clear screen. Back to annotate. So let's try this out. And I'm just going to do this on the screen, and I'll have to clear it each time, unfortunately. But going from 3,500 millimeters to centimeters, and we're just going to do a few of these. Annotate. So 3,500 millimeters to centimeters, or I can do them in different colors. That's what we'll do. So millimeters to centimeters. Here's our millimeter, and we got to go to centimeters, which is over on the right. So we got to go right once, twice. So it's because that went right twice. We're going to do the same thing. That's millimeters. Please, please, please excuse me. I need to start that over. I don't know why I saw that as meters. We're starting with millimeters and going to centimeters. Okay, fresh start, problem 25. Millimeters is right here. We're going to centimeters, which says we only have to go left once. So we're going to do the same thing to this decimal place. It's originally behind the 0 at the end. We'll move it left once. So that's going to end up becoming 350 centimeters. Switch my color. All right, how about 26? And we'll do this right on the first go, I promise. 9.8 kilometers to meters. Kilometers to meters. Kilometers to meters. So we're starting at kilometers. And we got to go to meters. It doesn't matter if you're showing the thing above or below or even at all. You can just count it off. So to meters, that's right. 1, 2, 3. So since that was right 3 times, we're going to do the same thing to that decimal place. Let me write it down here. 9.8. So write 1, 2, 3 times. There's filler zeros that need to be in there. So that's going to end up being 9,800 meters. About 27, 687 decimeters. DAM is the decameters, DM is the decimeters. Fortunately, you have the abbreviations there for you. We'll do this in blue. So we're starting with decimeters, which is here. We're supposed to end at meters. And to get there, we just move it left once. So do the same thing to this one. We move it left once. 687, the decimal is originally behind the 7. Going left once gives us 68.7 decimeters. So that is the entire idea behind converting units in the metric system. It is a completely different problem. It is so much easier as long as you what? Pay attention, which I did not do that at first at 25, but thankfully I paid attention after and I caught myself. Nobody's perfect, right? That's what I always say. But we pay attention, we make sure that things make sense, and we can catch little mistakes like that. Go back and make sure that the answers make sense after you've practiced these multiple times and have a better understanding. We'll do a couple more of these next time involving converting units of mass and capacity, but there's nothing different. Just like when we were doing mass versus capacity versus distance with the US system, it was all the same concept. This is all the same concept for the metric system. So again, we'll do a couple more problems next time. But I am going to say that we have done enough that I could make this section do, but given it's the first day of the new format, I'm going to play nice, and I'm just going to say, hold on. Oh, I got to clear my screen. So back up here, we only finished 2.12, so that is going to be due next class by midnight. So next class we'll finish 2.13, we'll do 2.14. We might even be able to knock out 2.15 as well. 2.15 is a very short section, so we might be able to finish chapter 2 next class. If you have any short questions, please email me. And yeah, hopefully this was helpful. Hopefully the recordings are helpful. Please stay tuned. We'll see you next class. Have a good day. Stay safe, everyone.